Hello everyone, today we are going to start our new lesson number 7, 10th grade, combination of capacitor, chapter 6, electrostatics. So I hope that all of you are doing well in your studies and enjoying your life as usual. So let's begin our lesson. Combination of capacitors. Combination of capacitors can be of two ways. You can combine capacitors in two different ways. You either can combine the capacitor in series or in parallel. You can see over here that capacitors of different size and shape and capacities can be connected in two different ways. That is parallel combination of capacitors and in series. So here capacitors in parallel. In parallel combination, you can see over here both these capacitors are connected in parallel way. When two capacitors are connected in parallel, their combined or total capacitance is simply the sum of their individual capacitance, that is C1 and C2. You can see over here the combination is the total capacitance is equal to the combined capacitance of both these capacitance. So if there are two capacitors over here, but if there are more than two capacitance, you can add up all these capacitance to find the total capacitance. This is because when two capacitors are connected together in parallel way, they are equivalent to a single capacitor with larger plates. The bigger the plates, the more charge they can be stored for a given voltage, and hence the greater the capacitor. The total charge on two capacitors connected in parallel and charge to a potential difference is simply given by this equation. So the charge is equal to the total capacitance multiplied by voltage supply. Keep in mind that the voltage in parallel combination, the voltage supplied, they are equal. It is equal. To summarize, for capacitor in parallel, the following rules apply. The potential difference across each capacitor is the same. The potential difference, they are same. The total charge on the capacitor is equal to the sum of the charges. That is, total charge is equal to the sum of the charges. Mean charge are not same. The total capacitance is given by C1, C2, C total is equal to C1 plus C2 plus C3 and so on. Now let's do some example. Question number 7, you can see over here the capacitors, they are connected in parallel and the voltage supplied is 120 volt, and we know that the rule that the voltage supply in parallel combination, they are same. So the parallel capacitor combination shown in the figure is connected across a 120 volt source. Determine the equivalent capacitance, the charge on each capacitor and the charge on the combination. Now here you can see for a parallel combination, the given formula is capacitance, total capacitance is equal to the combined addition of combined capacitance, that is C1 plus C2. So 2 picofarads plus 6 picofarad is equal to 8 picofarad. So 8 picofarad is the total capacitance of both these capacitance. And each capacitor has a 120 volt potential difference impressed on it. Therefore, we know that the potential difference are same in both capacitors. So the charge on the first capacitor is equal to C1. V is equal to 2 multiplied by 10 raised to power minus 12 farad multiplied by 120 volt. That is 0.24 nano coulomb. In the same way, you can find the charge on the second capacitance from the given equation, and after calculation you get the final value to be 0.72 nano coulomb. The charge on the combination is total charge is equal to Q1 plus Q2 is equal to 960 picometer, or you can also write charge is equal to total capacitance multiplied by voltage is equal to 8 multiplied by 10 raised to power minus 12 farad multiplied by 120. You can simply also use this equation and the final value is 0.96 nano coulomb. Now question number 2 is that you have to calculate the total capacitance of 200 microfarad capacitor connected in parallel. There are two capacitors connected parallel and each one of them have the same capacity, that is 100 farad. Calculate the total charge they store when charged to a potential difference of 20 volt. So you need to find the total capacitors of parallel is equal to C1 plus C2. You need to add up both, and the final value is 200 microfarad. The charge on total is total capacitance multiplied by voltage supply, that is 200 microfarad multiplied by 20 volt. You get the final value to be 4000 microcoulomb, sorry, which is equal to 4000 multiplied by 10 to the power minus 6 coulomb. Or simply you can write 4 microcoulomb. Now capacitors in series. Capacitors in series, you can see over here, capacitors are connected in series, not in parallel way. The total capacitance of two or more than two capacitors connected in series is given by this formula. 1 over total capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3. The potential difference is divided, or it is shared between the two capacitors, so that the potential difference across C1 is V1 and that potential difference across C2 is V2. Here the potential difference in these two capacitors, they are different. In previous one we learned that the potential difference across parallel capacitor, they are same, but in series they are different. So capacitors in series, you can see that the capacitor connected in series store the same charge. Here the charge are same. This allows us to write the equation for the voltage 1 and the voltage 2. V1 is equal to Q over C1 and V2 is equal to Q over C2. The combination of capacitors stores charge when charged to potential difference. So we can write V is equal to Q over C total. Substituting these in the value of potential difference, we get Q over C total is equal to Q over C1 plus Q over C2. Cancelling the common factor of Q gives the required equation, that is 1 over C total, 1 over C1, 1 over C2. Because we know that the charge are same, so the charge get cancelled. The remaining value would be 1 over total capacitance is equal to 1 over C1 plus 1 over C2. In this way we derive the equation for the total capacitance of a series combination. Now let's do some question. Calculate the total capacitance of a 300 microfarad capacitor and a 600 microfarad capacitor connected in series. Now we know that in series, in order to find the total capacitance in series combination, we can use this formula, and after putting the value in this equation, we get the final value to be 1 over 200. That is simply 200 microfarad. Calculate the total capacitance of three capacitors of capacitance 200, 300 and 605 microfarad. The series combination is connected to a 120 volt source. So these are the three capacitors connected in series, and the voltage supply is 120. Also determine the magnitude of charges on the capacitors. So first you need to find the capacitance of these three capacitors. So we will get the total to be 1 over 100, or in simply total capacitance is 100 microfarad. In a series combination, each capacitor carries the same charge. So charge Q1 is equal to Q2, Q2 is equal to Q3, and it is equal to all the charge, they are same, but the voltage are different. So the total charge is equal to the total capacitance multiplied by voltage supply. So the total charge is 0.012 coulomb.